Okay, so yesterday we worked with trigonometric identities and simplifying them using the other identities we have that are associated with specific trig functions. Today we're going to back burner that because I don't think I really want to overwhelm your brain anymore. So what we're going to do now is we're going to kind of switch gears and we're going to start thinking of our trig functions in terms of coordinates on a coordinate plane in relation to a circle. I know that sounded super duper confusing, but this is called terminal conditions. And all it is now, instead of thinking about our trig functions in terms of a right triangle, we're thinking about our trig functions in terms of a circle, as if they exist. Oh, wow. At some angle on a circle.
That's what my head looked like.
That's better.
I know I'm such a fascinating person.
Okay, on the circle, we're assuming our origin, so the point 0, 0 is the center. The radius then determines how far out my circle goes. So this length here is going to be the radius, this will be the radius, this will be the radius, and this will be the radius, just like it works on a normal circle. Let's assume then that I have some angle that exists on the circle. So let's say I have angle theta right here. This angle theta not only has an angle that's associated with it, but it has a point on the circle that is also associated with that angle theta. We call this our terminal point. And this terminal point P has coordinates x and y. Every single angle has a different terminal point unless they are coterminal to each other, which means they exist in the same place on the circle just with a different angle measure. So a point or an angle over here will have a different terminal point than the one over here. And one down here is going to be different than one up there. So all the points on the circle or all the angles have different terminal points associated with them. So of course, since we're dealing with trig functions, I have to find a way to relate all of my trig functions back to these xy coordinates on my circle. So somebody with way more time than us figured out that my sine, cosine, tangent, cosecant, secant, and cotangent functions, their ratios can be adapted to fit the needs or the information from my circle. So sine previously to us was equal to opposite over hypotenuse. Now, that is not true because I don't have an opposite and I don't have a hypotenuse. But from this angle theta, if I'm thinking about this point, my opposite side could be interpreted as my y, or vertical distance from the origin. My adjacent side then could be my x, which is the horizontal distance from my origin. And then the hypotenuse would be my radius. So now instead of opposite over hypotenuse, sine is equal to my y coordinate over the radius of my circle. So all we've done is we've taken that thought of a right triangle having opposite, adjacent, and hypotenuse, and adapted that into the x and the y coordinates of my terminal point and the radius of my circle. Do we all see how opposite corresponds to y, adjacent corresponds to x, and hypotenuse corresponds to the radius? Okay, so using that same logic, I can rewrite cosine. Since that used to be adjacent over hypotenuse, it now becomes my x coordinate over the radius of my circle. Tangent used to be opposite over adjacent and now is y over x. We do have the stipulation though that my denominator cannot be equal to 0. If it is, we say that that ratio is undefined. And of course, we have our other trig functions. So cosecant used to be hypotenuse over opposite. Now it is radius over y, where y cannot equal 0. Secant is hypotenuse over adjacent, which translates into radius over x, where x cannot equal 0. And cotangent translates from adjacent over opposite into x over y, where y cannot equal 0. So if I'm talking about my trigonometric ratios in terms of a circle, I'm talking about x, y, and r. I'm no longer thinking about O, H, and A. Yeah. So of course, we're going to do an example that uses this information, but I will wait until you're all done writing. I would highly suggest that you star this or circle this or box this in, because these ratios, so the x, y, and r, are going to be very important when we build our unit circle next week. Are we all okay? Colin, you still writing?
Yeah.
Okay, are you sure? Molly, are you still writing?
No.
You're good. Ray, honey, how about you? You're good. Give Marissa a second.
That's what Marissa got John.
We are, stop it. Stop it, stop it. After this example, we're a third of the way through what we're covering today, so chances are this is not going to take the entire class. Okay, just letting you know. Okay, so let's go ahead and do an example. I'm going to kind of zoom this out a little bit so we can kind of still keep it on the board with us. And I'm going to move it off to the side, that way I have more room to write. The example I would like to look at says if theta is an acute angle in standard position, so my fixed side is on that x-axis to the right, and my terminal side is what moved. On a rectangular coordinate system, and if the point I have is negative 15,8, find the values of my trig functions. If theta is an angle in standard position on a rectangular coordinate system, and if the point P is negative 15,8 is on the terminal side of theta, find the values of the 6 trig functions of theta. Okay, so before I can really start this, I need to figure out which information I have. What information do I have? I have x and y because I have a point where negative 15 is x and 8 is y. In order to find my 6 trig functions in terms of theta, what piece of information am I missing? The radius r. So think all the way back to when we did an equation of a circle. How do I find the r, or the radius of my circle, given a point that exists on the outside of it? Kind of a modification of the Pythagorean theorem. Anybody remember exactly what it is? Mallory? Very, very, very close. It would be, we do x minus 0 because we're assuming 0 is the center of my circle, squared, plus y minus 0 squared. So you had plus where it should have been minus. And then we fill in the x and the y that we have. So my x value here was negative 15, and my y value was 8. So I have that my radius is equal to the square root of negative 15 minus 0 squared plus 8 minus 0 squared. If I were to simplify this before I start squaring, I would have negative 15 squared plus 8 squared. And then I could plug that into my calculator and figure out what it equals. Of course, if my radius is a radical, I would like to keep it as that radical. I do not want the decimal approximation. So find out what that is.
$17.
Okay, well, I want the number under the radical first so we can all make sure we got that correct. When I do this, I get 289 because 15 squared is 225 plus 8 squared, which is 64, which gives me 289. Square root of 289 is 17. So 17 is the radius of my circle. So now I have the radius, I have my x coordinate, and I have my y coordinate. Do I need any other information to write my 6 trig ratios? No, that's all I need. So now let's go ahead and do that.
Yeah.
So sine is equal to y over r. So I just fill that information in. My y value is 8. My r value is 17. So sine is equal to 8 over 17. Yes?
Do we put 15 as positive?
No, 15 is negative.
Oh, okay. So you can have a negative.
I don't have a negative length. I can't have a negative coordinate, though. That's entirely okay, because I still have angles that exist down here, or up here, or down here. They exist all around my origin. The length, though, from the center is still positive, because my radius is still positive, no matter where it's at. Okay? So I have sine, then I go ahead and do cosine. What's cosine going to be? Negative 15 over 17, because it's x over r. I do the same thing with tangent. And when I do, I get 8 over negative 15. Because y is 8, x is negative 15. Then I go and do the next 3. So do the next 3 on your own, and we'll come together and share them. Erin, what did you get for cosecant? Perfect. 17 over 8, because it's out r over y. Secant, Becca, is what? 17 over negative 15, because it's r over x. And cotangent, Jojo, is what? Negative 15 over 8. My reciprocals still stand. So cosecant, which is the sine, I said cosecant, right? Yeah, cosecant, which is the sine ratio flipped, secant, which is the cosine ratio flipped, and cotangent, which is the tangent ratio flipped. Questions, concerns, or issues with that? So then let's say I'm not talking about any circle. Let's say I'm talking about a very specific circle called our unit circle. So this is primarily what we're going to deal with or work with in trigonometry. The unit circle is a circle that has a radius equal to 1. So if I were to draw my unit circle, it would look just like my previous circle did, except I know that the radius is equal to 1, which means the distance from my origin here to any of these outside points on this blue circle is going to be 1. This allows me to easily identify 4 quadrantal angles on this circle and the corresponding terminal point. Can anybody remind me what a quadrantal angle is? It's in your notes, we wrote it down. What is a quadrantal angle? Right, angles whose terminal sides lie on one of my axes, which means that it's going to be this 0 or 360 here. I'm gonna put money in. Or it could be this 90-degree angle here, or this 180-degree angle here, or my 270 angle down here. So it's angles whose terminal side, or the side that moves, that lies on one of my x or y axes. If I'm talking about this 0-degree angle or 360-degree angle, because they're both coterminal to each other, I know that my fixed side and my terminal side are in the same place, which means that it corresponds to a specific terminal point or xy coordinate pair. Anybody have an idea of what that coordinate pair is going to be? How'd you get 1, 0, Gabe?
Radius is 1 unit and its radius is 1 over.
Okay. So I like to think of it as from the origin of my circle to get to this point, did I move left or did I move right? Right, which means my x coordinate is +1. Then did I move up or did I move down? Neither, which means my y coordinate was 0. The x and the y here work the exact same as if we were plotting points on any other grid.
Where's the other part of the angle?
They're both on top of each other.
Oh.
Yeah, the terminal and the fixed are in the same spot. Does everybody see how that's 1, 0? So 90 degrees or 0 degrees or 360 degrees both correspond to the terminal point 1, 0. If that one's 1, 0, what's my 90-degree terminal point going to be? A 90-degree terminal point assumes that my fixed side was here and my terminal side opened up there. Oh, I'm hearing some mixed things. Okay, first question. From my origin to get to 90 degrees up there, did I move left or did I move right? Neither, which means my x coordinate was what? 0. Then did I move up or did I move down? Up, which means that my y coordinate is 1. So 0, 1 is a terminal point corresponding to my 90-degree angle. We're going to do this again for the 180-degree angle over here. What is its terminal point? So this is my 180. It assumes that my fixed side was here and my terminal side came over here.
-1, 0.
-1, 0, yes, because from my origin, I moved left 1, which corresponds to -1, and I didn't move up or down at all, so there was no vertical change.
Why? Okay,
You're okay.
why is the 90 not 1, 1?
Okay, so from my origin, which is in the center of the circle, did I move left or did I move right to get to 90?
Yeah, but why'd you write white on both things?
Because this is my fixed side and this is my terminal side, so it was created like this. I was just showing how my sides are different than they were over here. Okay? Does that kind of make sense? I'm trying not to confuse you, but I'm afraid I'm confusing you.
Yeah, you're fine.
Okay, so now because I just heard it doesn't make sense. Let's assume that I'm doing my 270 angle, which means my fixed side is here, and my terminal side traveled all the way around like this before stopping at that vertical line. If I made an angle that went from here to here, which means that my outside point stopped here, what is the terminal point associated with that angle? 0, -1. From my origin, did I move left or right to get to this point? Neither, which means my x coordinate is 0. Then did I move up or did I move down? Down, and we assume it's a distance of 1 because the radius of my circle is 1. So that point is 0, -1. So now you know the terminal points associated with our 4 quadrantal angles. Are we all okay with how we did that for the most part? I know it's hard. I do.
Why don't we count the other side of the angle? You're only doing the straight line, not.
What's the other side of my angle? I guess I don't
Like in the
understand.
90, you have the up and down one. You have like the one that goes to the right.
Well, the one going from the right is just where my side started. The one going up and down is where it stopped. So this one formed the angle by moving from that fixed side. So this means nothing to me. I only care about where the terminal side stopped. Does that make more sense? Okay. I was just trying to show you where it started and where it stopped and what formed the angle. Okay. So now I want to pick one of these angles, and I would like to find the 6 trig functions for that specific angle. I'm going to pick the angle 3 pi over 2. Which quadrantal angle is equivalent to 3 pi over 2? How do I change from radians to degrees? Oh my goodness, I'm feeling a pop quiz next week.
Pi over 180.
Multiply by 180 over pi. So multiply 3 pi over 2 by 180 over pi and see which of these degree angles it corresponds to. You're right. Ray, what'd you get? Okay, so I'm asking to find the angle associated with the radian measure 3 pi over 2. So how do I change radians into degrees? Yeah, so I'm just going to multiply this by 180 over pi, and you can put it in your calculator. And then it should tell you what the degree equivalent is. Ismail, what'd you get? 270 degrees, yes. So if you wanted to go ahead and write what the radian equivalents are, 90 is pi over 2, 180 is pi, 270 is 3 pi over 2, 360 is 2 pi, and 0 is 0. So now you have 5 degree and radian congruences. Say that.
Yeah. So excited.
Okay, so now that we identified which of these angles was equal to 3 pi over 2, let's go ahead and find the 6 trig functions for that 3 pi over 2 angle.
Oh.
So before I do that, I need to identify what my x, my y, and my r are so that I can go ahead and plug them in. What's my x coordinate for 3 pi over 2?
0.
0 right there. What's my y coordinate? -1. And what's my radius? 1, because I'm on the unit circle. So using that x, y, and 1, find my 6 trig function ratios. We are almost done with what we're doing today.
Thanks.
But we are finishing this lesson, and then next week we're actually going to build the unit circle on Monday,
Ooh.
which I'm super excited about.
Oh, I know. You're fine, figure it out.
Okay. as you get finished with your 6 trig functions, I have gone ahead and written the answers up on the board. Please check them as you move through and address any issues that you're having. I'm in high grade now. I went to get my daughter out of the car this morning and I totally like hit my head on my car door.
You're hitting her head on the
No, I hit my head. I'd rather hit my head than her head, but it still hurt.
I did that yesterday on my sister's car. Shook the car.
It hurts.
Did you like open the door?
Yeah, like I opened the door and I was like, hey, I'm gonna get her out, and I just right into it. She laughed. It was okay. Okay, is anybody having any major issues with finding the 6 trig functions for any of these for this specific quadrantal angle? And do you anticipate having issues with any of the others? I know sometimes the biggest question I guess some of you guys have is when is it okay to have a 0 in the top, and is it ever okay to have 1 in the bottom? So I don't know if it's helpful at all, but I try to show the kids this. So if the 0's on top, it's okay. If the 0's on the bottom, it's a no-no.
On code.
I don't know if that helps at all, but that's just something I like to show kids. Sometimes it helps, sometimes it doesn't. So if the 0's on top, it's okay. If the 0's on the bottom, it's a no-no. Are we all okay with those 6 trig functions in terms of 3 pi over 2? So let's now make a generalization. I know you're just so excited for that. When we were working on these, we identified that sine of theta, actually I'm going to switch it. We identified that cosine of theta is equal to x over 1, which is just x. So the cosine of my terminal of an angle is just the x coordinate of that terminal point. And my sine of theta is equal to y over 1, which is just y, which means that each of my terminal points is written cosine comma sine. So each of my terminal points corresponds to where x is equal to my cosine value and y is equal to my sine value. This only applies to my unit circle, which means that I can actually make some, assumptions or parallel, I lost the word. Okay, so this means that I can go ahead and state a few things I know about terminal points on the unit circle in general. So if I have a unit circle like this, we're just going to leave the circle part out of it because it really only deals with the quadrants. If I am in quadrant 1 over here, what do I know about the x and y coordinates for each of my points? They're both going to be positive because from the origin 0, 0, I went right, which indicates a positive x, and I went up, which indicates a positive y, which means that my sine values are going to be positive and my cosine values are going to be positive, which also means that my tangent values are going to be positive because tangent is sine over cosine. So that was just for quadrant 1. Does that make sense in how we kind of got there? So now let's go ahead and look at quadrant 2. From the origin, did I move left or did I move right?
I moved left.
I moved left, which means that which of my coordinates is going to be negative? The x, which means the cosine is going to be negative. Is my sine going to be positive or negative for that quadrant?
Positive.
Because I went up from the origin, yes. So sine will be positive, which means my tangent is going to be what? Negative, because positive divided by negative is negative. Then I look at quadrant 3, which is the bottom left. Is my x coordinate here positive or negative? Negative because I moved left from my origin right here. So cosine is going to be negative. What about sine? Also negative because I moved down from my origin, which means tangent is going to be what? Positive. Because a negative divided by negative is a positive. And then we're gonna have quadrant 4 over here. Is my x value going to be positive or negative? Positive, so cosine is going to be positive. Is my y coordinate here going to be positive or negative? Negative, so sine is going to be negative. And is tangent going to be positive or negative? Negative, because negative divided by positive is negative. So these are just generalizations that we can make based off of the positivity of each of my coordinates in specific quadrants. This will help us when we are asked to find an angle that meets certain criteria. So I would also like to point out a couple parallels here. If my sine is positive, what do I know about its reciprocal cosecant? It's also positive. If cosine is negative, what do I know about its reciprocal secant? It's negative. So if tangent is negative, what do I know about its reciprocal cotangent? Negative. So the reciprocals maintain the same sign that our original 3 do for that specific point. So the reciprocals have the same sign. If it's helpful to you, you can go ahead and write one set out. So cosecant here would be positive, secant here would be positive, and cotangent would be positive. Positive, not negative. Down here in quadrant 4, secant here would be positive because cosine is positive. Cosecant would be negative because sine is negative. And cotangent would be negative because tangent is negative. So the reciprocal holds the same sign. And then, of course, you could do the same thing over here, but I'm not going to. We have one more example, and then we're finished. Does everybody understand how the reciprocal holds the same sign? Okay. I will wait till we're all done writing, and then I will do the last example. No. Took me like 6 lines.
We're gonna do more examples.
Okay.
The one thing we did.
What's the identities one? We will not before this homework, but I'm not saying we're not going to. We're kind of doing it in batches. I don't anticipate that you guys are gonna just know exactly what you're doing on your homework for those questions, so I do anticipate we'll go over those on Monday.
Okay.
Yeah.
Because I got no idea what to do.
That's okay. If you guys honestly have no idea, that's fine. We'll go over them on Monday. I think there's 2 questions I gave you.
Yeah.
I think there are 2.
The first one's super easy. The second one I have no idea.
Okay, well, if you can get one of them, then that's awesome. Okay, so the last example of this 3-day note set. I know I'm so excited.
No, it's gonna be a 4-day.
No.
What's you like?
They got 2 in it. I'm gonna do the 2.
Okay, so this specific problem says, knowing that sine is equal to 3/5 and tangent is less than 0, which means it's negative, find the values of the other 5 trig functions. So this one is clearly not a unit circle problem because I don't have a whole number sine, which means I'm probably going to think about this in terms of a right triangle. That might be the easiest here. So I'm going to go ahead and draw that right triangle. We're going to assume that this bottom left angle is my theta. If that bottom left angle is my theta, do I know anything at all about the sides of my triangle? Yes, what do I know about them? Okay. Perfect. I know that my hypotenuse is 5 and my opposite is 3. which means I'm only missing one side. And how do I find it? Pythagorean theorem. I'm going to go ahead and tell you what that side length is, just because I don't think we need the Pythagorean theorem practice. Okay, Gabe, say it again. So that might be a hard concept for some of you to think about, because we're not used to a side length being negative. But I need this to be negative because I know that what trig function has to be negative here? Tangent and cosine. Because my sine here is positive, the only way for me to get a negative tangent, because tangent is equal to sine over cosine, and if my sine is positive, and I know my tangent has to be negative, what does that cosine have to be? Negative. So my cosine trig functions here have to be negative, which means my secant trig function here has to be negative because it's cosine's reciprocal, which means tangent and cotangent are also negative. The only way to make that happen is to assign a negative value to this adjacent side, because that's technically my cosine side. Which means now I can go ahead and build my trig functions. Yes, Colin?
Okay, I know I should know how to do this, but where did the -4 come from? Because isn't it a squared plus b squared equals c squared?
Okay, so yes, that's how we got the 4. And then I was just explaining. How many of you, hold on. How many of you have a problem with the negative part on this 4? Just Colin.
I get why it's negative, I just don't,
Okay.
I'm not understanding how it's 4.
Oh, a squared plus b squared equals c squared. So 3 squared plus x squared equals 5 squared. 3 squared is 9. 5 squared is 25. 25 minus 9 is 16.
Or you just square root it there.
And I got 4.
In my brain, I just couldn't. I was like, there's no way 9.
So the negative part we're okay with. If you're not, you really do have to tell me, because I do have an alternate way of kind of explaining it if you don't get the negative part. Okay, so let's assume that we did Pythagorean theorem like normal and identified this as +4, because I do like this explanation a little bit better. I just do. It makes sense to me. So we're going to do our sine, cosine, tangent, cosecant, secant, and cotangent ratios just like normal. And then we're going to fill in the negatives that have to happen. Okay, so let's go ahead and find all 6 of those trig functions. Of course, please do it on your own first because it's really good practice for you. And then I'll show you what we have to do.
Are we solving it for 4 or -4?
Let's use +4 in there, and I'll show you how we would do it from there, because not everybody's going to remember. If you know the -4 and it makes sense to you, use the -4. I'm going to show you as if we were using a +4. But it's going to work the exact same way. Just not everybody understands the -4 part, so I'm trying to show an alternate version. Okay, did we all get our 6 trig functions written? From the problem, I knew that sine was positive, which means cosecant is positive, and I knew that tangent was negative, which means that cotangent also has to be negative. We also established, due to that tangent identity, that cosine here also had to be negative, which means secant also had to be negative, because it's its reciprocal. So it is just as easy to go in at the end and fill in negatives where we needed them to be. It really doesn't matter which number we assign the negative to. But if you understood the -4 part of this, then please do it that way. Okay, so you can always do it at the end as well. How do we feel about that problem? Not bad. Anybody have major questions, concerns, or issues with anything we did today? We are going to do more with terminal conditions. We only identified the quadrantal points today. Next week, we're going to fill in all the rest of the angles. which thus fills in our unit circle. So B, making sure that you understand how we got the X, the Y, and the R and the trig functions from there, okay? Homework is on Canvas. Of course, I hope you've already been working on it. You have just a couple minutes, I think, to finish it up or work on it if you want to. Of course, you've been